Today we are starting exponential and logarithmic equations. Alright, we started this yesterday. It's the first problem where you guys probably would look at it and go, what in the world am I supposed to do? Number 4. So, some things we need to know, okay? E by itself is Euler's number. And the formula for Euler's number, E, is equal to 1 plus 1 over n raised to the power of n as n approaches infinity. It's an irrational number. It means like 2.718. Okay? So as n approaches infinity, it gets really, really, really close to this approximate value. So if you go to your calculator and you've ever just type in E by itself and press enter, you're going to get that 2.718. Now, E is dealing with the natural, E and the natural log go hand in hand. Something you guys need to know. You need to know that the natural log of E will always equal the number 1. This is something you need to have in your journal. Okay? So write down the natural log of E is equal to 1. And we'll just type it in the calculator. Natural log of, I'll just go up here and grab the E. And press enter. And that equals 1. The natural log is log base E. These right here are exactly the same. So if I said log base E, e to the power of 1, that's why it's just equal to a 1. This is something you should have in your journal already, because it follows the same pattern as this. Log base b of b to the power of x equals x. So this is the pattern that I want you to notice. This right here is going to be the same as me saying this. The natural log of e to the power of x will always just equal x, because these right here that I have in rectangular boxes, these mean the exact same thing. I go back to this problem. Right now we're dealing with e to the power of 2x minus e to the power of x minus 6 equals 0. Now there's a process that we're going to use. I want you guys to write the letter u. We're going to use a letter other than e or x or y. We're going to use the letter u. We're going to call u by itself e to the power of x. So I'm going to do a substitution method. Wherever I see e to the x, I'm just going to replace it with the letter u. That'll help us see things a little bit easier. So right now, instead of e to the x, I'm going to put a minus a u. Now, everybody, e to the power of 2x is the same as e to the x times a 2. So if I replace e to the x and I replace it with the u, now I'm left with u. And what's the only number I have left up there? 2. So u squared. So now I have u squared minus u minus 6 equals 0. Now your brain should recognize what to do with this more than what it should recognize to do with this. What I'd like you to do right now is I'd like you guys to factor this. I want you to factor this. There's going to be a u here and a u right there. You're looking for two numbers that add up together to equal a -1, and two numbers that multiply together to equal a -6. Alright, what did y'all come up with for numbers that work?
-3 positive 2.
-3 positive 2. That works here. It also works right here. So put u minus 3 and u plus 2 equals 0. Now what number minus 3 equals 0? 3. So u could equal a 3. What number plus 2 equals 0? Negative 2. So we have two answer choices, everybody. We have two. U could equal a 3, or u could equal a negative 2. Now we're not done with the problem, but now at least we know what is. We at least know what u is equal to. Now at the very beginning of this problem, I said, hey, we're going to substitute, wherever we see an e to the power of x, we're going to substitute it with what letter? U. So now I need to resubstitute. Reverse what we just did. So instead of u, what am I going to replace it with? E to the x could equal 3. Or e to the power of x could equal a negative 2. So right now, all I've done is replace the u back with my what? Back with what I originally substituted for, e to the power of x. We can actually solve for this. Over here, guys, in your journal, I want you guys to understand, e raised to a certain number will never yield us, it will never give us a negative value. So since e, if I took any number, all right, what I would say, e to the power of negative 3, okay? Or if I said e to the power of 1.171, whatever it is, what's this answer never going to be? It's never going to be negative. So knowing that it's never going to be negative, you guys need to understand when to stop working on a problem. So I'm letting you know, whenever you get a value that's a negative and you have e to the x equals a negative number, just stop working on it. Don't work any further. That's an extraneous solution. Don't use it. We are going to work with this part. We can finish this part. Okay? Now, what did I say at the very, 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 very beginning? That the natural log of e is always equal to 1. And what did I say? The natural log of e to the power of x is always equal to x. So what we're going to do is we're going to apply what's called the natural log to both sides of the equal sign. And the reason why we're applying what's called the natural log to both sides of the equal sign is the natural log of e to the x now is just x. Now, you guys remember the power property? What does the power property say? Whenever you're dealing with a logarithm, what are you allowed to do with this power? You're allowed to bring it where? Down, up, in front. So if I said, what's x times the natural log of e? If I just put that in a word like this on a random, no calculator, what's x times the natural log of e going to be? Because what is this by itself equal to? 1. And what is x times 1? X. So if I said the natural log of e to the x, that equals x. If I said x natural log of e, that also equals x. So that's why this right here, everybody, when I apply the natural log, what does this eventually become? This just becomes an x equals the natural log of 3. This is your exact answer. Now, type that into the calculator and you will get an approximate value for the natural log of 3. So in the calculator, I'm going to type in the natural log of 3, and I'm going to press enter. And what do I get? I get this really long number. I want you guys right now, just put, that's approximately equal to 1.099. That's good enough. That's your approximate value. Now, whenever you get an answer, you want to know what in the world are we solving for? What are we trying? How do we check it? Okay? So here's how we're going to check it. If I say e raised to the power of this, what should that equal? Should equal a 3. Now, why is it 3.00 all the way out over 1? Because the calculator is approximate. Okay? Now, Austin, what was our original question? Our original question was what? E to the what? E to the power of 2x minus e to the power of x minus 6. What was that equal to? 0. So if you really wanted to check it, all right, so the last thing I'm going to do is I'm actually going to do that whole process. E raised to the power of 2 times, what did we solve? What did we find x to be? That long one, right? Okay. Minus what? Minus e to the power of the same dadgum number minus 6. So if I type that in and I solve for x correctly, what should this equal at this point in time?
0.
That's not equal to 0. Well, you know what? That number right there is really close. It's a really small number. Because 4.97 e to the negative 9, that's really close to 0. Okay? Now, if I would have gone back up and not done the approximate, but done the natural log of e, the natural log of 3, it would have equaled 0. Okay? Our answer is, now, everybody, go to y equals if you would, please. What I want you guys to do is I want you guys to type in e power of 2x minus e power of x minus 6. Okay? So here we go. We have this right here. I'm going to hit graph. And now I'm just going to check. Second trace, I'm going to check where it's a 0. I'm going to go over here for my left boundary. You should start seeing a cursor soon. There it is. Alright, so right now, there's my left boundary. I'm going to press enter. For my right boundary, I'm just going to do a 2. So I'm going to type in a 2, which is right over here. So there's my left side, there's my right side. When I press enter, you guys see what the 0 is? Is that right there? Well, what does that not tell you? Does that tell you that that's equal to the natural log of 3? It doesn't. So what I need you guys to understand, if all they're asking for is approximate values, you can use the graphing calculator. But if you have to know the exact answer, you can't use the graphing calculator. You have to know how to solve it by hand. Okay? All right. Now what we're going to do is we're going to do numbers 5 and 7. 5 and 7 are more like something I'm expecting a high school student to be able to do without a whole bunch of help. So number 5 and 7, we're going to go and do those next. All right? We're going to show you some properties that you should be able to use in order to get these correct. The first thing I want you to do in problem number 5 is I simply want you guys to change it from logarithmic form to exponential form. Okay? So how do I write number 5 as an exponential form?
X raised to the power of 3 equals 64.
Very good. So everybody, this right here, this concept, how to change it from logarithmic form to exponential form, you must know how to do this when you take our first quiz coming up soon. Okay? Now, you guys should also know your 4s. You should know 4 to the first is 4, 4 squared is 16, and 4 to the power of 3 is 64. Okay? So 4 to the power of 3 should equal 4 to the power of 3. So this number right here has to equal what number? That has to equal 4. That's why the answer is 4. So this would be a quiz type problem where I'm expecting to be able to solve for x right here because that's the base. Change it to exponential form and solve. Number 7. What I'd like you guys to put in your journal is this. The natural log of A equals the natural log of B. This is another simple problem. I need you guys to understand when you have two natural logs equal to each other, and you see the natural log here, and you see the natural log here, you must know that A must equal B.
So 2x plus 20 equals 16.
That's all you have to do. You have to know that that's all you have to do to set this up. 2x minus 1 equals 16. This is a very quick problem. It shouldn't take you that long. So go ahead and solve for x, get that taken care of, and we'll move on to a more difficult one. Before we start number 8, I want you guys to look at number 7. want you guys to rewrite this. Instead of seeing the natural log, I want you to write log base e. The natural log is log base e. And we'll put 1 over e equals x. What I'd like you to do right now is I would like you now, on your own, change that from logarithmic form to exponential form. Change it from logarithmic form to exponential form. Alright, what do we get?
E to the power of x equals 1 over e.
Very good. E to the power of x equals 1 over e. Okay. That will be the case. Here's something you probably need in your journal. Any number raised to the power of 0 is 1. E to the first is just e to the first. E squared just stays e squared. I'm not going to keep going, okay? But if I said e to the negative 1, that means 1 over e. Just like e to the negative 2 would be 1 over e squared. So if I said e to the x equals e to the negative 1, because 1 over e is e to the negative 1, then yes, what does x have to equal? It has to evaluate to a negative 1. Okay? So right there, that will equal a negative 1. The last problem that we're going to do together today as a class, we're going to work through problem number 8. By the way, problem number 8, we are going to have to use the quadratic formula. In tomorrow's problem, you're going to have a quadratic formula, so you want to make sure you write down the quadratic formula and how to use it as we do problem number 8. We're going to do a little twist, all right? The last time, what did we say u was equal to the last time? We said u was equal to what? E to the power of x. This time, we're going to do a little wrinkle. We're going to say u is equal to e to the power of 2 times x. I'm going to explain why we're going to do that. Okay? So right now, in problem number 8 in your journal, I want you guys to write u is going to equal e to the power of 2x. We're going to do the substitution process again. Now before we get started, that's a 3, that's a 9, that's a 15. Thank God all those numbers are divisible by 3. So just to make things easier, everybody, the very first thing that I would do with this problem, just to make things look simpler, divide everything by 3. Now you have e to the 4x minus 3e to the power of 2x minus 5 equals 0. Alright, now that we've done this, what we're going to do is wherever we see this e to the power of 2x, we're going to replace it with what letter? We're going to replace it with a u. So we'll put minus 3u minus 5. Now before I replace this with u, I want you guys to understand e to the power of 4x is e to the 2x times 2. So right now, I'm going to replace this part right here. I'm going to replace this part with a u, so it would be u squared. So I'm trying to help you guys be able to see. Like, this part's easy, because you can see e to the 2x, that's just going to be a what? That's just going to be a u. But e to the power of 4x actually becomes a u squared, because this is the u and the 2 goes right there. So now, set that equal to 0. Now everybody, I need you guys to know this is a quadratic equation, but there are no two numbers in the world, integers, that multiply together to equal a negative 5, but they add together to equal a negative 3. Because what are the only factors of 5? 5 and 1. What does 5 and 1 get us? Either a 6 or a 4. It doesn't get us a 3. So since it doesn't give us a 3, we have to use the quadratic formula. So make sure you guys have this somewhere in your journal. Something that's helpful just to know by heart. It's helpful to know. Right here I'm going to say u, because that's basically basically, what we're going to be solving for, is equal to this. That's the quadratic form. Okay? So right now, my a value, everybody, is 1. My b value is -3, and my c value is -5. Now, whenever I'm doing the quadratic formula, the very first thing that I do is I find what's called the discriminant. So whenever you're doing the quadratic formula, by the way, you're going to be doing this tomorrow when you guys have a practice problem at the very beginning of the class. You're going to use the quadratic formula. Just give me a hint. Make sure you have that down. We're going to do what's called the discriminant. Oh, that's not how it's supposed to. Discriminant. There we go. There's the discriminant. So if I do the discriminant, I'm going to plug in a -3. I'm going to square it. -4 times my a value times my c value. This becomes 9 plus 20. So my discriminant is 29. So instead of writing all of that, what am I going to put in that pesky little radical sign? I'm going to put a 29. Okay? So here we go. -b. What's my b value? -3. So we'll put 3. Plus or minus, what am I going to write? What number am I going to write in the radical? 29. All over 2 times my a value. 2 times 1 is 2. So this is what u is equal to. So here's what I want you guys to write in your journal. All right, so we have 2 answers. We have u is equal to 3 over 2 plus radical 29 over 2. And we have u is equal to 3 over 2 minus radical 29 over 2. Now, I don't know if you guys know what the square root of 29 is, but it's definitely between a 5 and a 6. So what's the square root of 25? 5. And the square root of 36 is? And 29 is between a what? A 25 and a 36. So if I said 3 minus the square root of 29, this answer right here, everybody, this answer is going to be that's going to be a negative. Now what am I going to replace u with? E to the power of what? 2x. But e to the power of 2x. Well, e to the power of 2x cannot equal a negative. So this answer, once again, is what? What do we call that? An extra answer that doesn't work. Extraneous, good. So this is extraneous. So you know what? I'm not even going to worry about it. Not even going to worry about it. I'm just going to worry about this guy right here. So right now, what I want you to do is I want you guys to write. Put nice and big. E. Don't you know you're being recorded right now? E. Power of 2x. Good. My board heard you. No, it didn't. Equals 3 over 2 plus the square root of 29 all over 2. So right now, this is what you have. Now, whenever you guys are working in base E, what's the final step to solve for, to get x down from the exponential realm? What do I have to apply to both sides? Just remember, the natural log of e to the x is always x. So if I said, what's the natural log of e to the 2x, what would that equal? That would equal 2x. So what I'm going to do is I'm going to apply the natural log on both sides. Now what do you do with all of this? You just put it in the parentheses, okay? You put it in the parentheses. Now, what is the natural log of e to the 2x? That just becomes 2x. Now, most of you will probably divide both sides by 2, and you can divide both sides by 2. Alright? Well, what I'm going to do is I'm going to multiply both sides by a half. So my final answer, everybody, my final answer for x is 1/2 times the natural log of 3 over 2 plus square root of 29 over 2. This, everybody, is not an approximate answer. This is your exact answer. Now we're going to practice typing this in the graphing calculator so we can find our approximate value. Okay? But this is your exact answer. So, in the calculator, here's how you would type it. Let's clear everything up. 1/2 natural log. And in parentheses, what do I want you to do? You can do alpha y equals enter if you want. You can do 3 over 2 plus radical 29 over 2. And what's our approximate value equal to? Basically, I just want you guys to write 0.717. Just try to round your answers to the nearest thousand. Okay? Nearest thousand. This right here, if I said, everybody, our very first problem, right, when we started out, it said what? It said 3e to the power of 4x minus 9e to the power of 2x minus 15 equals 0. If you took all of this and just plugged it in here and plugged it in there, everything will equal a 0. Okay? If you plug it in, it will equal 0. So, what I want you guys to do right now is I'm going to help you guys start number 9, and you are working on number 9 all on your own. Here's the final problem that I'm going to start, but I'm not going to finish. There are two properties being used right here. Two properties of logarithms being used. The first property that's being used is the product property. The second property that's being used is the quotient property. So when you guys are doing logarithms, you have to be able to recognize which properties are being utilized. So I'm going to start the product property, and I'm going to write ln of 4 times x minus 5. Because you take 4 and the x minus 5 right here, and you multiply them together. Then you say equals the natural log of, and this is x, this is a 2, so you're going to put x over 2. So once you do the product property and the quotient property, then and only then can you set this side equal to this side. So this follows the equality property. The natural log of A, that's equal to the natural log of B. Then what does A have to equal? A has to equal B. So set this equal to this, which means you set 4 times x minus 5 equal to x over 2. And now solve for x. If you can solve for x, you got it right.